Now our next speaker is Josh Long, Spring Developer Advocate at VMware. So, welcome, Josh.
How many minutes do I have?
I think you have 40 minutes.
Okay, starting from 11:07, so 11:47. All right. Thank you so much for having me. I appreciate it.
Yeah, thank you too that you attend this conference. Really great to see you here.
Likewise.
Yeah.
Should I go?
So I think we can start. Yeah,
Okay.
sure.
Oh, okay, good. Oh boy. Okay, so thank you so much, everybody, for being here. I appreciate the opportunity to be before you today. I know that there are places that you could be anywhere else, and you decided to be here with us. That is wonderful, and I appreciate it. My name is Josh Long. I work on the Spring team as a developer advocate. I'm a Kotlin Google developer expert and a Java champion. And most importantly, I am at your service. If you have questions or comments or feedback, please send me a direct message on Twitter or send me an email. If you want to see the code, it's there. GitHub.com, Josh Long, Cloud Native Java, where I trust that you'll be able to find everything you need. But if you don't, again, you can email me or send me a Twitter. As part of what I do, I used to travel a lot. I used to, before the pandemic, I used to get around a lot. And I do training videos, and I have a book called Cloud Native Java that I wrote in 2017. And I have a podcast that I do every Friday. There's a new episode out today with my friend Shigeru Urishibara-san or my friend and inspiration, Shigeru Urishibara, or Mr. Urishibara, or Urishibara-san from Japan. He's an amazing engineer and contributor to the Java ecosystem, and he's also a businessman who has a company on the Japanese stock market. So go listen to that podcast. Lots of great people in the Spring community. And of course, I have a blog every Tuesday. I look at all the news that's fit for reprinting, for review. Every Tuesday for more than 10 years, I've been doing this. And of course, I have a screencast called Spring Tips, where I do a video that introduces a new topic every week. And of course, I have a new book called Reactive Spring. Now, these are all things that you can find out about me. But today, my friends, we're going to talk about how to build reactive, scalable microservices. And when we do this, what we are trying to do is to build cloud-native applications that will scale and that will respond gracefully to change, and that will support high-performance organizations. So I have moved away. I don't have any clicker or anything like that. So let's just talk for a few minutes, okay? When we talk about building cloud-native software, what we are doing is we're building software that is meant for organizations that want to improve quickly. The goal here is to build software that makes it easier for human beings, people like us, to evolve, to change, to grow, to respond to marketplace forces, and to change in response to those forces. This allows us to build better software faster. This is not about one technology. I love Spring, obviously, but it's not about just Spring. It's not about cloud computing. It's not about any of this. Anybody who says that cloud native is about technology is lying to you, or they don't know, right? Either way, that's a problem. When Netflix talks about cloud native, when they talked about it 10 years ago, when they first coined the term, when we first heard these terms, what they were talking about is a set of practices that allowed them to respond more quickly to change. And so there are a lot of things that we can do in an organization that slows down our ability to change, to grow our software. We can we can have large code bases. These large code bases mean that there's lots of people working on the code base. And the more people you have, the more synchronization and integration and stabilization that is required for every single new release. This is a problem because it's very hard to scale. So what organizations do is they take their large code base and they break it apart into small code bases. These small code bases have small teams, but it's very important that these small teams are able to work independently. They're able to see movement into production without having to wait for other parts of the organization. And so they look for parts of the application that can be described by themselves, that stand by themselves. These independent services are called microservices. When you hear people talk about microservices and they say it's about small code bases, I think that's misguided. It's really about small teams. How small is the team? Well, it depends, right? Obviously, Werner Vogels and Jeff Bezos and Amazon, they talk about 2 pizza box teams, a team that is so small that you can feed everybody on the team with just 2 boxes of pizza, 2 delivery boxes of pizza. So what this means is, 5, 6, 7, 8, 9 people, something like that, very small amount of people. And they're all working on one thing, one service, product management, user experience, developers, testers, administrators, all these people in one group working on one thing. That way, if there's work to be done, it goes very quickly. There's no wait time, there's no queuing, there's no inventory, no lean manufacturing waste, right? So all of that is very important in delivering software into production. So you have now a bunch of microservices, small microservices. The question then is, how do you handle the complexity that comes from this, right? When you move to microservices, you have distributed systems, and this is where things get very complicated. So today, my friends, what we're going to talk about are techniques that we can use to make the work of building services quickly and reliably and getting them to production more easily. To support us, we're going to look at reactive programming and a lot of different cloud computing principles. Reactive programming is a great way to build software that has 3 qualities that become very useful in a microservices context. The first quality is resource efficiency. How easily can I reuse the threads in my application so that I don't waste, so that I'm never sitting there in my code on the JVM waiting for the next byte to arrive. I'm never just waiting. I'm never doing that. I don't want to do that. I want to always have my threads busy. This is the first thing, resource efficiency. The next thing that I care about is reliability. How well can I handle failure in my services? If something disappears, if the network fails, if a service goes offline, how well can my services respond to that failure, to that service outage, to that topology change? And the third and final thing that I care about here is ease of composition. How readily, how quickly can I take data from message queues and REST endpoints and server socket events and service end events and RSocket and WebSockets and all these different things and compose them and combine them and make them into a new stream, right? If you have 20 different APIs, one for RabbitMQ, one for Kafka, one for REST, one for WebSockets, one for all these different APIs, then it's very hard to glue the APIs together into one new value, into one new stream of data. But reactive programming makes it very easy to compose, to combine all this data because you have one API, one kind of abstraction. And it doesn't matter if the data is synchronous and very, very small, or if it's asynchronous and very large, or even infinite, it still works. You have one kind of stuff. So let's talk about that, my friends. Let's go ahead and build a new service. Here at start.spring.io. This is my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. You should go there as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It is better than Disneyland. But if you have not already been to production, then you can begin your journey here at start.spring.io. And what we're going to do is we're going to build a new application called the customers application. And this application is going to have a few dependencies that we want. First, we will bring in Lombok. Lombok's a compile time annotation processor. We're going to bring in the reactive web support. We'll bring in R2DBC. We're going to bring in H2, and we're going to bring in the actuator. And I think that's it. I think I'm happy with that. We have an embedded database. We have SQL database access. We have a web server. We have Lombok, and we have observability support here. I'm going to go ahead and hit generate, and that'll give me a new zip file. Let's go to my downloads directory where that zip file is, and I will open this up in my IDE. Okay, voila. So that'll start up my IDE. All right. Once this gets started, you'll know that it's just a regular Spring Boot application. Okay, so this is all GA code, nothing special. And this application is going to write data to a database. And this database will be a embedded SQL database. So it'll just be a database in my local code base that'll run when the application starts up. Right. So here we go. There we go. I think that's not very different, is it? Let's make this a little bit bigger. 26. There you go, my friends. nice and big. Okay, so I'm going to create an object to write data to the database, private integer ID and private string name. Okay, so we're going to write this to the database. I'm going to map this to a record, to a Java object in my code, and my Java object needs getters and setters and toString and all that kind of stuff. So I'll use Lombok. Lombok is a compile time annotation processor. I'm also going to create a repository, and the repository is going to handle the boring read, write, update, delete. It's going to handle all the work of making it so that I can then talk to that database. This interface has a method, has a bunch of methods here: save all, find, check if it exists, count, delete. All of that is pretty obvious. When you implement this interface, Spring Data will provide an implementation of this interface that supports all of these different methods for you. So you don't have to worry about writing that code yourself. These methods are fairly obvious. You can look at the names and understand what is happening, but you may not be familiar with these types. The first of which is a publisher. Publisher comes from the Reactive Streams specification. Reactive Streams are a set of interfaces that were created by the Spring team, by Netflix, by Lightbend, by the Eclipse Foundation. All of us, several years ago, we got together and we created this Reactive Streams specification. And it is a way to describe asynchronous, unbounded streams of data. A reactive stream publishes data asynchronously to a subscriber. The subscriber can then read the data in the onNext methods when each new record arrives. It can handle the errors in the onError method if there are errors, and it'll finish up its processing in the onComplete method. Now, I skipped over this because this is very important, and I wanted to spend some time on this. When the subscriber subscribes to the publisher, it will have a subscription, and that subscription is what the subscriber uses to request more data or to cancel the data. So this is very important. The subscriber controls the speed that it reads the data. It controls the speed at which it consumes the data. This allows the subscriber to move as fast as it can, but no faster. You cannot denial of service something like this, right? It's very stable in a production environment. This is what you want to build reliable services. So we have three types: publisher, subscriber, subscription. There is a fourth one. The fourth one is called a processor. And this is a source and a sink, a publisher and a subscriber, a producer and a consumer. And that's it, my friends. Those four types are the reactive stream specification. If you understand that, congratulations. You're already years ahead of most people in Silicon Valley. I live in San Francisco in the United States, in the state of California. I am very, very close to Silicon Valley. Take my word for it. You're doing great. That said, remember that those four interfaces, the biggest thing is that subscription. Behind the scenes, this subscription allows us to support flow control. Sometimes you will also hear people talk about back pressure. It's the same thing as flow control. It's the ability of the subscriber to push back against the publisher to stop it from producing too much data. So these types are very basic. They're very useful. They're so useful, in fact, that they are now part of Java itself. So Java util concurrent flow.processor, flow.subscription, flow.subscriber, and flow.publisher. These are very basic, and so you can use either Java 9 or later, and of course you are going to use Java 9 or later, and you can use the reactive streams types. They're interchangeable. There's even a flow adapters class that will allow you to convert from a Java util concurrent flow publisher to a reactive streams publisher, or vice versa. Okay. Now, that said, these are data flow abstractions, and they're useful, but we need more. So for this, we have Project Reactor. Reactor provides two types: Mono, which is a publisher as well, and if you speak Spanish, this is not a monkey. It's a publisher that produces 0 or 1 value. Think of it kind of like a completable future that supports back pressure. And there's lots of operators. Look at all these operators. Thank goodness that you do not have to write all this code and that I don't have to write it, right? This is a lot of stuff like flat map and filter, etc. We also have Flux. A Flux is a publisher that produces 0 to n values, where n can be anything. It can be 0, 1, 2, 5, a trillion, or infinite. Okay, so we have now our reactive repository. Let's write some data to the database. I'll create a Spring Bean that will initialize the database when the application starts up. And I'm going to implement application listener. application, or actually I'll just create application runner, right? Application runner. And I'm going to implement that method, and I'll have a callback here. Private final customer repository. So I'm going to inject this collaborating object as a argument in the constructor, through the constructor there. And I'm going to use that to write some data to the database. So let's create some names. We'll create a reactive stream of names like so, flux.just. Let's see, we're going to go through and get some people from the Spring team. Madura, we've got Olga, we've got Violetta, we've got, let's see who, Yushin, we've got Dr. Sire, we've got Stefan, we've got Spencer, and of course we've got me. Okay, so there's just 8 names in the reactive stream that are on this, a reactive stream of names of people on the Spring team. And now for each name, I want to visit each name and turn it into a new customer like this. So that'll give me a, that's a customer, there you go, customer. And that'll give me customer objects, but those have not been saved to the database. And so I'll visit each one of those. I'm going to map each one and write it to the database using the repository, .save C, okay? Now, this will give me a reactive stream of customers. And the reason I used flat map is because if I do map, I get this. I get a flux of mono of customer. What I want is a flux of customer. So I will take the inner reactive stream, this mono, and I will flatten it so that I only have one stream. So I use flat map, okay? So flat map var, and you can see this code now works better. I can just remove this and remove that. Here we go. Saved, okay? There's that var. Good. So there's the reactive pipeline. I have defined the steps through which data will flow to get written to the database. The problem is that if I run this code, nothing will happen. I have connected the pipes together, but no water is running. I have not turned on the faucet. I need to subscribe in order to get the results. The problem, of course, is that subscription is asynchronous. It takes time. And so I want to make sure that if I do something like this, that when I do something afterwards, that I don't that I do one thing first and then the other thing next. So what I actually need to do is I need to also initialize my database. Remember, I have an embedded database. So I'll say private final database client dbc, and I'm going to inject that, and then I'm going to create the database. I'll say var ddl equals dbc.sql create table customers customer ID serial primary key name varchar 255 not null, and I will say fetch, and I'll say rows updated. So that'll be the update, and then this will be the write over here, and then I want to get all the data back, right? So I'll say var all equals customer repository dot find all. Now I've got my 3 steps: create the table, write some data, read the data. I want one thing to happen before the next. So I will use the operators to make sure that these things happen in a particular order, okay? And I'll just subscribe to the final step there, and I'll print out the results. Let's go ahead and run this and see what we are given, okay? Let's run it. Here we go. Compiling. Okay, there's our application. Did it work? It doesn't look like it worked. I did something wrong, my friends. Let's see what I did wrong. Find all. Oh, there you go. Then many names. We want saved. There you go. That's what we want. We want to save the data. Otherwise, we won't get anything back from the find all. And by the way, I wrote this code, slowly so that we could see what's happening. But normally, I would just write something like this. I would chain the method invocations together, one after the other. Okay, so it'll be names. There we go. So it worked. Look at that. We have our 8 records. It worked. Of course it worked. It was a demo. That's not why we're here. What I wanted to talk to you about, as always, is this ASCII artwork. Just look at this. It's gorgeous. It's beautiful. This artwork took a long time. We on the Spring team have many people who are dedicated people who work on ASCII artwork, and it makes me very happy to imagine that someday, somewhere, there was a GitHub issue that said, we need good ASCII artwork, and I think you can agree the result is amazing. It's for this reason that I want to take a brief moment to talk about what I consider to be a very serious problem with the IntelliJ IDEA JetBrains IDE. Do you see this checkbox right here? This checkbox is a dumb checkbox. I don't know why it's there. When you click on the checkbox, it removes the ASCII artwork. My friends, do not click that checkbox. It's a terrible idea. Nobody asked for it. Nobody wants it. Now, I have an application. I want to build a REST endpoint, okay, a REST controller. So I'll say Spring. I'll use the REST controller annotation here, REST controller, class customer REST controller. And I'm going to inject my customer repository, and I'm going to get a git mapping customers, get that, return this.customer repository.find all. So I'm injecting the collaborating object, and I'm creating an HTTP endpoint there that'll serve up the data as JSON data. Okay, so it's a REST endpoint. I can go ahead and restart this. Now, I am very happy that I've got my service, and I want to take this to production. So the very natural thing to want to do here is to containerize it, right? So let's just make sure that this works, right? There's my data, it's working. So now I want to containerize it. Thankfully, Spring Boot supports something called a build pack. Build packs make it very trivial to take your application and containerize it. So I can do maven spring boot :build -image. I could do that, and eventually, after 1 minute, it would create a Docker image that I could then Docker tag and then Docker push, and then I could deploy to Kubernetes with kubectl apply, right? No problem. But what I want to do is I want to make my application a little bit more responsive. I want to also reduce the memory footprint. And so we have support for native images using GraalVM in Spring. It's using a project called Spring Native. And I could do a whole talk on this as well, but I won't. I will just add one dependency here, Spring Native. Same thing, right? It's the same exact build as before, except I've now added this experimental, not yet GA, library called Spring Native. And here I'm going to take the code. I'm just going to copy the XML here, and I'll paste it in my build, overwriting what I had before. And you can see that this has contributed a plugin, a Maven plugin called Spring AOT, and it has configured the build pack to produce a GraalVM native image. Okay, so everything else is basically the same, except that we've got Spring Native in the dependency as well. Now I can now run this. I'm going to run this build command, and this will take several minutes to finish its work. That's okay. We will step away and we'll go build another service, and we'll let this run in the background. Okay, so we have an HTTP service called customers. Let's go to start.spring.io and build a new service, this one using RSocket and Lombok. Okay, we're going to hit generate. And this service will not use the HTTP protocol. It'll use the RSocket protocol. RSocket is a binary protocol created by Netflix and Facebook that supports a lot more features than HTTP or gRPC. It's very flexible, and it's also natively reactive. It supports backpressure at the protocol level. It also supports different kinds of message exchange patterns and so on. So it's a very good protocol. And because it's natively reactive, it's built on Project Reactor. And so because it's built on Project Reactor, it's easy for us to support it in Spring. So we built a component model to integrate it, make it easy. So here's our RSocket server port. And we're going to create a different microservice this time, but not for customer data. Instead, I'm going to have an in-memory list of orders. So customers have orders, 1, 2, 3 orders, right? One to many. So I'll say that the ID for the order and the customer ID will be here. Now, this is a microservice. And so, in microservices, you don't have foreign keys. You don't have links. But sometimes you have a correlation key, right? This is a correlation key for the customer service that we just looked at. Now, we're going to need to have an order RSocket controller. And so I'll say at controller. By the way, how's this going? See this from the background? You cannot see this. You cannot hear it, but my computer is really upset with me. It's very angry. You can hear the fans going like crazy. GraalVM takes a lot of RAM and a lot of processing power. It's like Slack. You can't run both on the machine, Slack or GraalVM, not both. I have 64 gigabytes of RAM, and I would fear if I had anything less. Now, I am going to build my application, and it's going to have some made up dummy data, right? So let me create a constructor here. And in the constructor, I will set up the application with some sample dummy data, okay? So private final map of integer, and we'll have a collection of orders, okay? New concurrent hash map. Good. There's this. Now, for var order ID equals 1, order ID is less than, for var customer ID equals 1, customer ID is less than or equal to 8, customer ID plus plus. So I'm going to, for each one of the orders, I'm going to create so many random orders for each one of the customers. Now, orders list equals list, new array list, okay, order, and I will create a random number of data. So for order ID equals 1, order ID less than or equal to some number here, some random number times 100, order ID plus plus. And from there, I want to now add to the orders list, add new order. And I'll add the order ID here and customer ID. All right. So I'm just adding random data here. I'm just adding random numbers so that we have something to work with. I'll say this.db.put customer ID, and I'll put the orders list in there. And there we go. So there's my random endpoint, my random data. Now let's create an RSocket controller that responds to RSocket requests. And this will look very similar to using Spring Web Flux. So I'll say orders.customer ID, and I'm going to return a stream of orders, right, for a given customer. So destination variable, integer customer ID, return this.db.get customer ID. Okay. So obviously I should handle some of the other use cases here, var list, and I'll turn that into a reactive stream. So I'll say return from iterable list, okay? There we go. So that's going to run. Let's go ahead and restart this one. Let's see what that one does. In the meantime, has the other one finished? It's almost done. Look at that. This is almost done in the background. And we want to test. I showed you how you can test the HTTP endpoint using the browser. You can also use curl for the HTTP one. For RSocket, there's a great utility called RSC. So TCP localhost 8181. The route is called orders, and then we provide the customer ID. And the exchange type is called a stream. Okay, stream. There we go. There's our data. So we have an RSocket endpoint and we have an HTTP endpoint. Let's now compose both of these. We're going to talk to both of these. So in order to do that, we're going to create a new microservice called an API gateway. And the API gateway is a great place to add common, generic, cross-cutting kinds of concerns. It's like aspect-oriented programming for my network services. So I'll use Spring Cloud Gateway, which is built on Reactive APIs. I'm also going to use Lombok. I'm going to use RSocket. I'm going to use the Reactive web support. Okay, so I have a number of different things that we've looked at already. I'm going to act as the client to those things. I can create two things, API adapters and API gateways. Let's see here. This is finished. Look, it's finished. It has created a Docker image. So I can say Docker run minus P 8080 colon 8080. I'm publishing the Docker port and running it. And there you go. The application starts up in 0.147. Normally, if you are running this without screen sharing, you'll find, for me at least, this usually runs in less than 1/10 of a second. But because I'm on a screen share, it slows down a lot. Okay, so the application's up and running. I've exposed the port here, actually. So there you go. You can see the endpoints there. So very, very quick and much smaller footprint, maybe tens of megabytes of RAM, not hundreds and definitely not thousands. So now I can take my application and deploy many instances into my Kubernetes cluster and pay the same cost as I would before for a regular JVM-based application. This is a much better situation for certain kinds of workloads. Also, if you're doing serverless, this is very nice, right? Docker run, blah, 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 okay? Now, I have my service. Let's go ahead and run this here. So Maven, actually, let's just leave that running, I guess. That's fine. Okay, so I've got my HTTP service, I've got my RSocket service, and I've got my new gateway module. So UAO gateway.zip. Let's open this up. And here I'm going to look at Spring Cloud Gateway. Spring Cloud Gateway is an API gateway, kind of like Apigee or Kong or something like that. It's not a network gateway. So if you want to do routing of certain protocols in a certain direction, this is a level too high, right? But it's an API gateway. So if you want to do rate limiting or security or token relays, or you want to do session retries or circuit breakers or adding headers or anything like that, this is a great technology to use. So we use Spring Cloud Gateway, and it's very simple. The API is very, very simple. You can create a route locator, and you can use the route locator builder, RLB, and you'll say return rlb.route.build, okay? rs dot, and here I have to describe as many routes as I want. I can have one or more routes per application. I'm going to have a route, and the route has to do three things. First, you match the incoming request. Second, you filter it and process it. And then third, you forward it. So here, I'm going to match any request that goes to the service, running on port, what am I going to say? Server port equals 8888. Anything that goes to port 8888 / proxy, and that has a host header of spring.io, right? Wildcard spring.io. If this matches, then I'll send it to localhost 8080 / customers. But the problem is, it's going to take my request that has this path, and it's going to send it here to this path. Well, we don't have a localhost 8080 / customers / proxy. So what I need to do is to change the incoming request. And here I can do this by using a filter. I can say that the incoming request, I'm going to drop the path that comes in, change it to become customers, and then I'm going to send that to this. The power of Spring Cloud Gateway is in these filters. You can see we have retry, you can do add response headers. I can do cores, for example, access control allow origin. You can see I can do circuit breakers. I can do all sorts of very interesting things here. But let's go ahead and run this and see what happens. Okay, so this one right here. Here we go. Now, API gateways are great, but what I also want to do sometimes is to take data from one service and from another and compose them into new ways. This is something you would do to support different kinds of clients. Maybe you want to provide a view of the data that's for your iPhone or for your Android device or your tablets or your PlayStation or your Xbox or your refrigerator or your car or whatever, your smartwatch. All these different clients may have different views, different understandings of the data, so they have their own endpoints rather than sending them directly to the downstream service. In my case, it wouldn't even work because I have HTTP and RSocket. I don't want to make every single client speak both protocols, right? So I can create a class CRM client, and my CRM client is going to deal with the customer data here, right? You can see we've got customer data. I'll copy and paste. This is a terrible thing to do. Don't copy and paste. Obviously, you should do the right thing. Be the change you want to see in the world. I'm also going to go get the order data from this type here. So where's my, oops, wrong one. Actually, I'll copy and paste both of that. Put that here in the gateway. Good. And then remove, I actually accidentally added the customers to the order thing here. Good. So now back in my gateway, I've got both customer and order. Now I want to consume both of those. So I'm going to create a Spring Bean that is a client to both the RSocket and the HTTP service. In order to make this call, I'll use the web client, the reactive non-blocking web client, and I'm also going to use the non-blocking RSocket requester. Okay. And the RSocket requester is a RSocket client. I need the factory. I need to vend or produce instances of both. So RSocket requester.builder, return builder.tcp localhost 8181. Okay, so that's the RSocket connection. Notice that I have to specify the connection on startup, because once you start up, you stay connected. You don't have to constantly make the network call and do the handshake each time. This is much faster. It's much better for performance and latency. Then we also have the web client, HTTP web client.builder, and I'm going to build my non-blocking client here as well. And I'm going to use these down here in my CRM client. So I have a couple of endpoints, right? I want to get the reactive stream of orders, right? Orders for integer customer ID. So we say return this dot RSocket requester dot route orders dot CID customer ID. And then when the data comes back, I want the data to come back as order.class, and that's it, right? That's the RSocket network call. I want to do the same thing for the customer data. So I'll say publisher of customer, get customers, and here I'll return this.RSocket, this .http.get.uri, HTTP localhost 8080 / customers .retrieve .body to flux customer.class. All right, good stuff. So now I've got my network call. Now, of course, things might fail, right? And so the nice thing about the Reactive APIs is that you have operators like retry, and it can do retry. It can do retry with a back off, 10 duration of seconds, right? This kind of thing. I can do just a basic retry. I can do on error resume. So if I have an exception, I can decide how to respond to the exception. In this case, I produce a reactive stream. And these operators are not, they're not HTTP or RSocket. They're reactive, right? So I can add them to both calls, and they work the same way, right? That's nice. So now I've got my RSocket and my HTTP clients. Now I want to compose them. I want to create a new view of the data here very quickly. So I'm going to create a view of the data called customer orders, right? So private customer, private list of customers, okay? Good. And this is the view of the data at allRx constructor, at noRx constructor. I want to create a new view of the data. So I'll create this new here, this thing, publisher of customer orders, get customer order. So I'm going to call both services at the same time and compose them into one stream. So flat map C, and I need to create both of them. I need to hold the customer and the orders for that customer in memory. So I'll use a tuple. I'll say mono.zip, mono.just C, and I'll also use on the right here, I'll say, okay, give me the reactive stream. Give me the reactive stream of orders for C.get customer ID. And I want to turn that into a list. Okay, good. So there's this. Let's see. Come on. Go. Good. And then from that, I'm going to map it, each one. I'll have a tuple, and you can see the tuple has two types. It has T1, which is the customer, and T2, which is the list of orders. So now I can create a new composite type tuple.get T1 and tuple.get T2. Okay, and that's it. That's the definition that I want. So private final, let's see, list of customers, collection of customers. Is that what this is? Okay, good. Oh, I want the list of orders, right? Yeah, I knew I was missing something obvious. Okay, good. So that's my new reactive stream. You can see that that's very easy to write, very easy code to understand. It's making network calls concurrently. Now let's quickly stand up a controller, and we'll see that in action. So class customer orders rest controller, and we're going to create an endpoint using our CRM client, and we'll say at get mapping COs publisher of customer orders get turn this.crm client.get customer orders, and we'll just inject that into the constructor like so. Let's go ahead and restart. Here we go. Do not start. Okay, good. Now, this is a very simple example, my friends. I hope you have seen some of the possibilities here. We can build more robust, more efficient, more scalable, more production-ready software very quickly using the different things I've shown you today. And there's so much more, of course, right? RSocket, I've only begun to show you the very basics here. There's so much being done there. I've shown you Reactive Web, but there's so much more there as well. So let's see, 8888 / COs. Let's see if that works. There's that. And if we want, we can go curl -h host test.spring.io / localhost 8888 / proxy. Isn't that what I said? I think I said proxy for the gateway code, gateway proxy, right? So it's got a host header and gets the data back. But if I do spring.com, which is, it's not going to match the wildcard, I get a 404. My friends, thank you so much for your time. I hope you got something. I hope you're healthy and safe and happy, and I hope that we can meet again, maybe in person one day. Thank you so much, and I'll answer questions now.
Thank you very much. It's really great talk. I think it's also live coding. It's really amazing. So
Cheers. Thank
we have some questions. So we
Please.
have a question from the Artem. Hi Josh, did you have a chance
Hi.
to evaluate JDK records? I mean, do you plan to replace Lombok with records classes? Thanks.
I can't wait. I love Java 16. It's finally there. I've been talking about records for the last two versions because it's been a preview feature. We have support in Spring already for records in certain places. So, for example, for Spring Data and for message conversion over web. But obviously, not everyone is using Java 16. I think it's amazing. Java 16 is amazing, right? They have multi-line strings, var. We have records. We have lightweight pattern matching. Just an amazing job. Yeah, records are awesome. I can't wait. I love Kotlin for that reason as well. It's very concise,
Yeah, great. Yeah. The second question from the Dimitro about: do you prefer reactive streams concepts before React Java 3, flowable, and etc? Why?
So Project Reactor is RX Java and Project Reactor sit here. Here's reactive streams down here. So it's foundational. They're siblings. They are related to. They're next to each other. In fact, the project lead, David Karnock, the project lead of RX Java, is a major contributor to Project Reactor. We work together to describe the reactive streams. So you can use Project Reactor with RX Java, or you can use RX Java with Project Reactor, which means that if you have RX Java code and you want to use that code with Spring, that's okay. As long as it supports publishers, and it does, it'll work just fine. Observables and singles from RX Java are also publishers, just like Flux and Mono. So I like Reactor because it's right there and it works great. But if you already have business logic in RX Java, that's great. You can use it too, right? Just bring it to Spring.
Yeah, great. The next question is: prefer GraalVM?
Sorry?
Prefer GraalVM?
Prefer? Do I prefer?
Yeah. Probably it was
I think it's
for you.
really amazing. So remember, GraalVM is mostly OpenJDK. There is a custom hotspot compiler that's in GraalVM, and there's also this native image support. So I like the hotspot, the new, the GraalVM just-in-time compiler. I think is amazing. It's really fast, and that's valuable. If you also use the native image technology that I just showed, that's amazing as well. Obviously, it's a very new technology. Not everything is perfect, and there's still work to be done. But you saw that for lots of different applications in Spring, it works just fine out of the box. But obviously, we have work to do. There's the ecosystem is huge, and we cannot make everything work on GraalVM instantaneously. It takes time. So come along with us on the journey. We'd love to have your feedback and your help, and we'd love to help you as well.
Yeah, great. So the next question: when we can expect Spring Native as general available?
Good question. I don't know, but the big picture here, the big picture is Spring Boot 3 and Spring Framework 6 will have Spring Native will be inside of Spring Boot and Spring Framework. Most of that will not be a separate project anymore. So that's the big picture. I don't know when that will be. I guess that's next year, I guess. I don't know. Nobody tells me. But that's the long-term horizon. I hope that we will work on Spring Native, and then we'll see a general availability build of Spring Native for Spring Boot 2x and Spring Framework 5. And then eventually we'll get to Spring Framework 6 and Spring Boot 3, and then that'll just be part of it. So I wouldn't be surprised if I saw some GA releases in the next year. And and who knows, if there's
great.
enough demand, maybe we'll do a release, soon. I don't know. I have no idea.
Yeah. it can be also delayed or something like that. Yeah. Also, we have a question about, is there reactive H2 driver already exists?
Yeah. So when you use R2DBC, it's our reactive relational database connectivity abstraction. There's drivers for H2, Oracle, SQL Server, Microsoft SQL Server, Oracle, SQL Server, H2, MariaDB, Postgres, MySQL, Google Cloud Spanner, SAP HANA. I'm sure I'm missing some. There's a lot, right? A lot of different drivers out there, and you can go to start.spring.io and you'll see a lot of them, but that's not all of them. So the list keeps growing. Oracle just released their driver just like a week ago. So thank you, Oracle. Amazing. They released Java 16 and an R2DBC driver for Oracle. Oh, so cool. Thank you, Oracle.
Great.
Awesome.
Yeah. I'm also waiting for it. For the Oracle.
Wonderful. They've been doing such good work for the Java ecosystem.
Also I have a question. Josh, do you have similar demo for Spring Security?
Yeah, you can do reactive Spring Security, no problem. You can do Spring Security on RSocket, and you can do Spring Security in the web. You can do OAuth. You can do all that. So OAuth to client resource and client and OAuth to resource servers are both supported with GraalVM as well. So, lots of power there.
Yeah. Also, we have a question from Ivan. What is your next book going to be?
Oh, that's a great question. I just finished the Reactive Spring one a few months ago. I think I want to write whatever I write about. I think I want to cover Kubernetes and native images and something like that. I don't know what it'll be, but I've got in my mind. I think there's something worth describing there, and maybe something on Kotlin. That's another book I wanted to write, is a Kotlin book, because reactive programming gives you the ability to then use coroutines, Kotlin coroutines, which is awesome, right? Super, super cool. Like, it makes your code more imperative, and it's easier to understand for some people. So you still get the benefits of reactive APIs. You get the scalability, but you also get very easy to understand imperative, kind of code. And it's very concise, very clean.
Yeah. Also, next question. Do you anticipate whole Spring framework having 0% of reflection in the future?
No, and we don't need to, right? GraalVM they're improving all the time, so that they're finally able to support more of Java. Remember, what happens is GraalVM is a closed world ecosystem, right? So it needs to know about everything, and it hates surprises. GraalVM hates surprises. If you surprise it, it gets very, very angry. It hates it very much. So in order to make it happy, you need to feed it information so that it knows what dynamic, surprising things you might do. So loading classes, doing proxies, loading. It's not just reflection, by the way. It's also like if you load a thing from a jar, if you load an image or a property file, there's no jars in GraalVM, right? There's no class path anymore. So you need to tell it about this stuff. So we're not trying to get rid of loading things from the jar, right? That'd be silly. That's a bad goal. So instead, all we have to do is provide the configuration for that. But we do have some things that we're doing to reduce, where appropriate, the reflection. So when you use our Spring native support, we have a Maven plugin called the Spring AOT plugin. And there we are already doing some code generation to replace Spring.Factories with a Java class. So Spring.Factories is like a service loader text file. Instead of that, we're using a code-generated Java class, and hopefully in the next few months, or leading up to later this year, we're going to also introduce an experimental project called Spring-init. Spring-init takes your @configuration class and turns it into functional configuration. This is it requires less reflection. So again, that produces applications that are even easier for GraalVM to compile. But the goal will never be to remove all the fun things that Java can do. The goal will be to make it so that your applications work seamlessly with GraalVM, and where possible, to get GraalVM to be smarter about these use cases. Right now, the perfect application for GraalVM is like something like C++, right? No reflection, no dynamic behavior, no dynamic loading, nothing like that, right? It wants a statically linked binary, and that's not Java, right? So we need to meet in the middle. GraalVM wants like no fun. The Java ecosystem wants lots of fun. We need to meet in the middle somewhere. So that's what Spring Native does. Is it helps both sides find a place where they can agree.
Okay,
By the way,
great.
the GraalVM team, amazing. I don't want to. I'm only kidding about when I say it hates, but you get the idea. I love the GraalVM team. They have done amazing work.
Yeah, I agree. So great. Then, thank you, Josh. Really great talk.
Thank you so much.
Yeah, it's really amazing. For me, it's also I have
Thank
something new to learn.
you. Very cool.
And to see. Yeah.
What time is it in
So
your
thank
part
you,
of the
Josh.
world?
For me, it's 8 p.m. For
Okay.
guys, it's 9 p.m. Yeah.
Okay.
So
Oh, very
yeah,
good. Good evening to you. I appreciate you taking the time.
yeah. Thank you. Have a good day, probably for you. Yeah. Bye.
Bye.